as well.
Mm-hmm. Is there any other way to find the coordinates at that point?
I don't know actually. That's about as much as I know how to get that point.
Sure. No, that's what I'm curious about. Okay, so you can find this equation, you found this. Can you do it for any line?
Yeah, I think so. It also depends on some scenarios because this is referred to as naked math, and in naked math you can find a line that goes past the boundaries. But say for example, if you want to do something like if you wanted to put an equation for the amount of money that you make or earn for a given time, you're not necessarily going to be able to go even backwards because that wouldn't make sense because the x-axis is usually related to time and you can't go backwards in time.
Okay. So let's say, going off of that statement that you just said, if I were to say a scenario like you hired a plumber, right,
Mm-hmm.
to come do work for you.
Mm-hmm.
Let's say your sink started going crazy and you couldn't get any. And so when he shows up, he says, okay, I have a fee, and it's $50 to show up, which, by the way, most appliance repair people do.
Mm-hmm.
And then he says, okay, I'm going to get there, you owe me $50, and then for every hour I work on it, I'm going to charge you another $25, right? Could you write me an equation that represents that?
Yes.
Go for it. Here, let's do a different one for you.
Okay. So what you described was a linear relationship. So I'm going to go back once again to the mother function of f of x is equal to mx plus b. You gave me the initial amount, and the initial amount in these problems or scenarios tend to be the y-intercept, because the y-intercept also describes is kind of where the graph starts. Without the y-intercept, it's always going to be at 0, and the y-intercept is actually what's going to guide the line to be going from a certain direction. So in this case, so far we have our piece of $50. I'm gonna remove any signs of context just for the sake of the equation itself. So even though that's 50 and I don't have a certain dollar sign or dollar value to it, it's still gonna be representing the $50. And you said what was the amount?
$25 every hour.
$25 every hour. It's gonna be 25x. I do this because I know that x is the value that's always going to be changing, and when you're dealing with this, x is going to be the value that you can put on into the context to make sense. So for example, if I wanted to, I could do 25x where x is like 5, meaning that's 5 hours. So 50 is always going to be the thing, it's always going to be included. You're never going to have a moment in this situation where you're not going to pay the $50 up front. So the 50 is going to be what you're starting with, and so 50 is also going to be a point on there to start with.
Okay.
And then the 25 represents the rate of change, the rate of amount of money that's being paid in regards to x, where x is the amount of hours that the plumber is there for. And so in my example, I have x being 5, meaning for 5 hours that he's there, you pay the $50 up front, and then you pay $25 per the hour, which in this case you pay $25 per 5 hours, and so that's going to be $125.
Okay, all right. So let's see if I had another one, because this one had some pretty high numbers. How about we try, you're going to, let's say it's simpler, like it's only $5 to show up, right? And it's only $2 an hour.
Okay. Sure thing.
And so is that also, like these, you started with the graph, can that turn into a graph?
Yes.
And how would you do that?
So in this example, I could go by my calculator and put in the graph, but alternatively, what you could also do is, in real life scenario, let's say you're given this rate, and let's say you don't have a calculator on hand with you, but you're like, the guy's coming here, but I kind of want to know what it'd be like if he stayed for like 2 hours. You know the x value, so then you can do f of f of whatever hour you want, because that's what the function is graphing for. So let's say I want him to be there, or I expect him to be there for, say, 3 hours. So I'm going to do f of 3 equals 2, 3 plus 5. Now it's just any other regular thing where you can just do 2 times 3, 6, and plus 5, which is 11. So that calculates the amount of total, and on the graph then, that also means that at 3 on the x coordinate grid, then it's going to be $11. So I go over here 3, and I go up 11 here. So then that's the point of 3, 11. Meaning at 3 hours, according to this graph, I'll know that if he stays for the 3 hours plus the initial $5 that I paid up front, then in total it's going to be costing me $11 for the plumber to see me.
Okay. And could you do more? I mean, is that also a line with a constant rate of change?
Yes.
So could you finish the line for me?
So to finish the line, I'll need another point. So I'll just do 2 of 5, let's say. So this time he's gonna stick around for 5 hours, plus the initial $5. So that's 10 plus 5. That's 15. You can also write as f of 5 is equal to 2 times 5 plus 5, which is 15. So then over here I'll have a point at 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. That's gonna be where 15 would be past the drawn line. That's gonna be 5, 15. Then I can use my ruler and connect the point. I also need to worry about the y-intercept, and since I talked about before, the y-intercept is whatever is not changing or given up front in these cases. 5 is going to be my y-intercept, so I need to also graph 0, 5. 0, 5 being there. Because I said how before it guides the direction of where the graph is going. So in this case, your graph can only start at where the y-intercept is. So the line can't go any lower on the y-axis, hitting less than 5. So now that I draw my line, and since the real world scenario, I can only worry about this quadrant, because you're never gonna have a point where hours or time being negative, because that wouldn't make sense, and the only time that you would go into negatives if you were owing money.
I got you, okay. So, where does the constant rate of change show up on this graph?
The constant rate of change shows up in this graph? It shows whenever it takes however so long to get to the next point that hits the graph. So in this case, if I go over 1, up 1, I'll hit it here. If I go over 1, is it up 2? Right, my bad, it's up 2. So if I go over 1 and up 2, I'll hit the points on the graph, including the ones that I talked about. I don't know if that's what your question was asking.
Oh, it's whatever you're thinking about. It's
Okay.
exactly what I'm asking.
Okay.
Okay, so how would you find the coordinates of that point right there? Like if I draw this point right here.
Okay. Like before, I don't know the specific x coordinate to deal with, but since it's in between the two ticks, I can only assume that's gonna be 0.5. But that's usually how these scenarios go. So I would say that's gonna be a point of, since it's in between two. Sorry.
Oh, sorry.
It's between the tick marks on both the y-axis and the x-axis. It's not going to be a nice grid-like number. But I can see here, this is in between 2 and 3. So I would say this is going to be 2.5. This is in between 9 and 10, so I'm going to say this could be 2.5 and 9.5. And that's how I would graph it to be like that.
Okay, alright. So, is there any other way to find?
Yeah, this is going to be more calculator relying because that's what I always kind of fall back on. I could put in this equation that I have here, which is 2x plus 5. If I go to my table, though, it only scales from 1 and onward, so you're not going to be able to see it. So what I could do is if I go to table set and change the scale to 0.5, meaning now it counts by halves. If I go here to the same thing, I can find the point. Which is actually a lot different than what I expected it to be, because now it's giving me 2.5 y coordinate 10 rather than 9.5.
Alright, so let's say that this one is 2.5 and you didn't know the other one. How about if I do how about this point here?
That point there?
Mm-hmm.
Okay. If I wanted to find that point, again, I don't have the specific x coordinate, so I can only really eye it from there and assume it to be half, because I like to count by halves when we're talking about in between the whole numbers. So since that's that's half, that's also in the negative realm now, so this could be negative 0.5, since this is going to be less than 1, so I'm going to say that's negative 0.5. And on the y-axis, I'll know that to be 1, 2, 3, 4. So that's going to be negative 0.5, 4.
Okay, so you have the 4, right?
Mhm.
Is there any way that you could find out what that value actually, like remember you got surprised over here?
Mm-hmm.
How would you be able to go ahead and determine that one if you already know that that one is 4? Is there some way to do that? Would you went to grab that, so you would use the calculator?
Yes. Because it's a lot more accurate and a lot more precise as a machine, and when I put a graph in it, it will give me the rest of the lines that I have not graphed or accounted for.
Mm-hmm,
So I just look in here, and since I still have the scale to be 0.5 or a half, I can go to my table, go under the values for x, look for negative 0.5, and I look over into the y coordinates.
Yeah. And it gives you 4 this time?
Yes.
Okay, cool. So if you didn't have the calculator, would there be any other way to do it?
Not that I know of.
Okay, cool, sounds great. Well, Kang, you've been a very big help for me. I really, really appreciate you spending time here.
Mm-hmm.
And you've taught me a lot. You really have.